All right, so now we'll introduce the equations of kinematics. Okay. What we'll be doing is, so we'll here's the object to keep in mind. There's the axis of rotation, and there's its angular velocity, and what we'll consider as constant angular acceleration. That is, this is either speeding up at a constant rate or slowing down at a constant rate. Okay. And what this formula gives this, I won't go through any of this derivation. What this formula gives is, so when angular acceleration is constant, if angular acceleration is constant, this tells you how fast, what will be the angular velocity. And these are just magnitudes. What will be the magnitude of the angular velocity? Okay, so final angular velocity is equal to initial angular velocity plus alpha times time. So after this time, how fast will it be going? And that's what this equation is. Okay. What this formula does is, so if this is rotating, it has an angular acceleration. So through what angle has the object rotated? So through what angle has it rotated? This is the initial angular velocity, and the time that has elapsed, 1/2, there is the angular acceleration times time squared. Okay. So this is the angular displacement after this time. Okay. Or this is also gives you the angular position as a function of time. So for instance, theta final is theta initial plus omega times t plus 1/2 alpha t squared. And remember, we kept saying that if the position is a quadratic function of time, angular acceleration will be constant. Okay, and that's what this formula is expressing. Okay, so again, angular displacement as a function of time. Okay. And what this formula gives you is the angular displacement. So again, for constant angular acceleration. Okay, so here's what this formula tells you is the final angular velocity square is equal to initial angular velocity square plus 2 times alpha times the angular displacement. Okay. And so there's the velocity as a function of displacement. Okay. This final formula will occasionally use as a angular displacement through what angle has the object rotated. And that's equal to the final angular velocity plus initial angular velocity divided by 2 gives you the average angular velocity times time. Okay. So those are the kinematic equations. And again, these are valid only as long as acceleration is constant. Okay. All right. So these so this slide summarizes the kinematic equations. Again, these are for constant acceleration. So this is linear motion along a straight line. This is rotational motion about a fixed axis. And you saw that so the final velocity was initial velocity plus acceleration times. The corresponding formula is final angular velocity is initial angular velocity plus alpha times time. The final position as a function of time.